Welcome to Business Psychology Podcast.
Ready to dive into something kind of wild. We're talking large language models, those LLMs everyone's buzzing about, and get this, their supposed math skills.
Yeah, it's a bit of a head scratcher. On one hand, you've got these AI systems pulling off these feats with numbers, right? They get really complex stuff. But
This new research paper, it's called GSM-Symbolic, Understanding the Limitations of Mathematical Reasoning and Large Language Models. And it kind of throws a wrench in the whole AI math genius thing.
it does make you wonder if they're really reasoning like we do, or if it's more like, super advanced mimicry, like they've just gotten really good at patterns from all that data they're trained on.
Okay, so how'd they test that? How do you design an experiment to see if an AI gets math?
So they built this thing called, like I said, GSM-Symbolic, and it's specifically made to evaluate this whole mathematical reasoning thing in LLMs.
All right, break it down for me. What makes GSM-Symbolic so special for this?
So picture this. You take a math problem, any problem, and you change little things, like the names in a word problem or swap out some numbers, but the actual steps to solve it, the underlying math, stays the exact same.
So, like, if I understand addition, it shouldn't matter if it's 5 apples plus 5 apples or 100 cars plus 100 cars. Same idea, just different scenery.
Exactly. And this is where it gets juicy. What they found is LLMs. They're all over the place with this. One minute they're acing a problem, 90% accuracy. Next minute they get a version with different names and boom, down to 60%.
Whoa, that's a big difference for the same math, isn't it? What's that tell us?
Well, it's a red flag, right? Makes you think maybe they're not little math whizzes after all.
Hmm.
Amazing at pattern recognition, sure. But when you need that flexibility, that real problem solving, that's where things get iffy.
So just dressing up the problem differently, even if the math steps are identical, throws them off.
It seems that way, like they're relying more on those surface level clues in the problem itself than actually understanding the math behind it.
Fascinating. Okay, so if changing the wording messes them up, what happens when you make the math itself tougher? Did the researchers try that?
Oh yeah, they did. They started messing with the complexity, adding clauses, removing them, making the problems longer and trickier just to see how the LLMs would handle it. And, well, let's just say they weren't acing those advanced calculus exams or anything.
So tougher math trips them up. Got it. But here's where it gets really interesting for me, this whole no-op statement thing the researchers threw in. What's the deal with that?
Okay, so think of it like this. You've got a math problem, right? Like someone's buying apples and oranges at the store. A no-op statement would be like, oh, and it was a sunny day. It's true, it could be relevant, but it doesn't actually change the math you need to do.
So it's like a distraction, basically, a red herring for math problems. What happened when they did that? Did the LLMs just ignore the extra fluff?
You'd think, right? But nope, they totally fell for it. Adding those no-op statements, those irrelevant details, it tanked their accuracy, like sometimes by a whopping 65%.
65%. Seriously. Just from adding in a random fact about the weather? That's wild. What's that tell us?
Well, it seems like they're not as good at filtering out irrelevant information as we are. Zeroing in on what actually matters to solve the problem. They're grabbing onto anything and everything, even if it doesn't make a difference to the math.
So instead of cutting to the chase, the core logic of the problem, they're getting lost in the details.
That's what it looks like. And that little quirk, that tendency to fixate on the irrelevant, that's a pretty big deal, especially when you start thinking about using LLMs for, complicated real-world problems.
Right, because the real world, it's full of irrelevant details, isn't it? So if they're struggling with this in simple math problems, what does that mean for more complex situations?
Exactly. And that's what makes this research so important. It's a reality check. These LLMs, they're powerful. They can do some amazing things. But we got to be careful about assuming they understand things the way we do.
So where does this leave us? If they're fumbling with basic math, even with those curveballs, what happens when you throw real-world problems at these LLMs? Those are messy.
Right. And that's the big question, isn't it? This research is a good reminder, to not get ahead of ourselves. We can't just assume these LLMs get it the way we do, even if they spit out the right answer sometimes.
That's like, I don't know, teaching someone to bake bread by showing them a million pictures of loaves, but never giving them a recipe or explaining yeast or anything. They might be able to fake it for a while, but...
Exactly. There's a difference between mimicking something and actually understanding it. And when you're talking about something as, important as reasoning logic, that's a big deal.
Huge. So takeaway time, what should our listeners be thinking about, especially when they hear about AI doing all this amazing thinking?
I'd say a healthy dose of skepticism is never a bad thing. LLMs, they're powerful tools, no doubt could change a lot of things, but we got to use them responsibly. Part of that is being honest about what they can and can't do.
Right, and this deep dive, it's been eye-opening, to say the least. LLMs, they're still kind of a mystery, aren't they? Lots of potential, but lots to learn.
Absolutely, but all that's what makes it so interesting, right? Each study like this gets us a little closer to figuring out how these systems tick, what they're really doing in there.
Well said. And on that note, that's all the time we have for today's deep dive. We hope you enjoyed this little journey into the world of LLMs and math. And who knows, maybe next time you hear about an AI solving equations, you'll stop and think, but are they really? Until next time, stay curious, folks.